Hello calculus classes. So today we're going to take a look at section 5.2. I'm going to try and do a few examples from the papers, the notes that you have. So the first example is going to be example B under net signed area. So our first thing is we're trying to graph these first and see what geometric shapes we've got. So let's see if we can get this one graphed first off. Remember, you can just make a little XY table if you want. I'm going to go from -5 for sure. I'm going to definitely use 4 because you want to plug in those endpoint x's, and maybe another point in the middle. I'm going to put in a -2 here. And when I plug it into my function, I'm going to have -5 plus 2, which is -3. -2 plus 2 is 0. And I picked that -2 because I was hoping to get a 0 here. You'll see why. And then I'm going to plug in my +4. 4 plus 2 is 6. And if I graph these points, I'll have a good picture. We're going from -5 to +6. So our first ordered pair is -5, -3. Let's put it in. I have -2, 0. And my last point was +4. 1, 2, 3, 4. And then up, I'll just label that 6. And connect. It's going to be a line. And remember, these areas are between our graph and the x-axis. So here's one, a little triangle here, that's underneath the x-axis. And over on this one, I've got another triangle that is above the x-axis. So to find the net signed area here, what we're going to do is find the area above and then subtract the area below. They're both triangles. So first off, my area above is this top triangle. So I have 1/2. The base is going to be, let's count it, 1, 2, 3, 4, 5, 6 times the height. And the height of this triangle is also 6. And that's going to be the triangle that's above. And then I'll say minus, and then the triangle underneath here, this little triangle that's below the x-axis, is going to be 1/2. The base here is 1, 2, 3. And the height is also 3. Just use positives here. We're just finding these areas of the triangle. And let's see what we've got. So this would be 36 over 2, which is 18, minus 3 times 3 is 9, times 1/2 is 9/2. And then when we subtract that up, I'll get 27 over 2 as the net signed area. Alright, the next problem we're going to take a look at is part E, again from that same section from the net signed area. This is part E. And if I were looking at this, it looks pretty complicated. I don't really want to graph it the way I see it, but a way that you can make it easier on yourself is to break everything apart. And this is how we can do it. I'm going to have my integral from 0 to 2 of just 5 dx, and then minus, right, 2 times this. I can put the 2 out in front of the integral sign if I want, and I do want to. And then the 4 minus x squared, that's square root, and that will be my other piece. And I can do each part individually and then put them all together. So let's see if we can graph. First one is just y equals 5, or f of x equals 5. That graph would look something like this, from 0 to 2, And then your height here is 5. Just a horizontal line. And I can see if I look at the area of that graph to the x-axis, it looks like a little rectangle. So I can definitely find that area. The next one, if I was graphing just this part, okay, you can still use your table if it helps you. If I plugged in a 0 and I plugged in a 2, if I put in a 0 for x, I'd have 4 minus 0, and the square root of 4 is just going to give me a 2. If I plug in a 2 for x, I'd have 4 minus 4, which is 0, the square root of which is 0. This is going to be that quarter circle shape, so let me sketch it out for you. So I had the point 0, 2 and the point 2, 0. This is going to be a little part of a circle. It's a fourth of a circle, and we should be able to find that area as well. So first the area here, these are both above the x-axis, so I'm just going to, put all of this together. The first one, a rectangle, is going to be length times width, so 2 times 5, right? And that's going to give me 10 for that area. Over here, the area of a circle is pi r squared, right? And we have to take a fourth of it because this is just a fourth of the circle, so we will multiply it by a fourth. My radius in this piece of a circle is 2, so it's going to be pi times 2 squared times a fourth, which really just gives us pi for this part. So let's see what we've got. The area of that little rectangle is 10. Don't forget that we had a minus 2 here out in front, so I still have a minus 2 times, and then we took the area of this little piece of the circle, which was just pi. So my answer is just 10 minus 2 pi. So this is the last problem I'm going to do. This is number 1 from the piecewise functions section. You can see that this function is broken up into parts, and we're still trying to find this area here between the graph and the x-axis. So first off, let's break them apart. For x is less than or equal to 0, I'm going to use f of x as being from negative 3 to 0, right? The absolute value of x plus 3. And then I'll add that to this part from 0 to 5. We'll use the x plus 4 part. Again, let's see if we can just sketch each of these up. So the first one, if you want to use a little set of ordered pairs, I'm going to definitely use negative 3, and I'm going to use 0, the endpoints here. If I plug a negative 3 plus 3 is 0, and the absolute value of 0 is 0. For 0, for x, I'd have 0 plus 3, the absolute value of 3 is 3. So these are just points on that. And that graph would look something like this. From negative 3 to 0, I've got negative 3, 0, and then 0, positive 3. It's a triangle, which we know we can find that area. For the second piece, from 0 to 5, I'm going to pop in 0 and 5 to see what it looks like. 0 in for x, you get a 4. 5 in for x, you would get a 9. So this graph would look something like this. From 0 to 5. We'd have 0, 4. I'm just going to label it. and then 5, 9. Another little line. And when I drop this down, you can see that this little area is actually a trapezoid. And we've got that area formula on your sheet. The bases, this is base 1, over here is base 2, those are the parallel sides, and here the height is right there. It's a trapezoid on its side. And we know how to find that area as well. So let's see if we can put our areas together. This one, the triangle, is going to be 1/2. The base is 3, and the height is 3, plus this trapezoid is 1/2, base 1, which it is going from 0 up to 9, so that's a 9, plus base 2. Base 2 is from 0 to 4, so that's 4, right? Times the height, which is from 0 to 5. That's a length of 5 there. And this is what I would have that one. So let's see. This will be 9/2. Over here we've got, let's see, 9 plus 4 is 13 times 5. What's that? 65 over 2. And when we add those together, we get 37 for our area. 37.